mean that the data is going to be collected for the digital transformation. We are going to collect the data which is already existing in the plant. For example, we may have the turbine generators or steam turbines, which is running inside the plant.
Hi, Sir
So
JP.
once you have, sorry, yeah,
Sorry to interrupt you once again, but there is really some problem with the audio. Yes. Um,
you are able to see hear properly, or it's kind of
we're yeah, it's the audio is kind of choppy on some parts of your presentation earlier.
oh, sorry.
Mm, no
Okay,
problem, sir.
okay, let me continue, and then if you really could not able to hear anything, just interrupt me.
Okay.
Okay,
Hi, Sir J. Thank you
so
so much, Sir
once you
JP.
have, okay, so here properly, or we go to the
We're
equipment
yeah,
health
it's the audio is
services.
kind of
So
choppy
the asset management
on
and
some
equipment
parts of your
is
presentation earlier.
almost identical.
Mm, no
Okay,
problem,
it,
sir.
okay, let me continue, and then in the kind of assets you really could not able to hear anything, just interrupt. For example, the equipment
Okay.
health service is mainly
Thank you so much, Sir
on the
JP.
rotating equipments health monitoring system. It mainly helps to increase the reliability and reduces the downtime of the particular equipment services. So the asset management and as part of operational excellence, we are providing a solution that will improve the safety and profitability, because when you go to the industry, the safety is the more priority than anything else. So our operational excellence ensures that the customer can achieve the safety and profitability. It mainly helps to increase the reliability and then the remote services the downtime of the particular equipment. This is very most needed services with the COVID pandemic, because our engineers cannot travel because of the COVID restrictions, and we are offering the remote services so that the required maintenance or required advices can be done remotely by logging into the system and analyzing the logs collected from the particular equipment. So that kind of solutions come under remote services. And then the sustainability. Uh, we'll be collecting the data to analyze the equipment's performance, that will help to reduce the emissions that is coming out from the industries. So it is mainly targeting to reduce those emissions and then go screen. It's an agenda. Finally, the OT cybersecurity. Uh, those these as far as we have seen, all these solutions are mainly concentrated on connecting the system to the internet, uh, so that this data will be analyzed and provide the solutions. So that is a real threat. So there are a lot of risks involved when you are connecting the data or sending the data out from the plant to the internet. So our cybersecurity solution ensures that these threats are identified and your assets are protected in, and we provide the response and recovery products in case of incident happens during the digital solutions. Let me stop here. If you have any question, or if you want to get any clarity on what we discuss, uh, maybe we can discuss it again. Otherwise, I will continue. Okay, let me continue. In between, if you have any questions, put it in the chat window. When I have time, I will review. I have allocated some time for the question and so until now we have seen what are all the different services that is coming under Siemens OmniWave solutions. Now we are going to going to have some detailed overview of the solutions under each services that we discussed before. Okay, let me go into one by one. The first service that we are going to talk about the asset management. As I mentioned, this asset management solution is to mainly to extend the asset life and reduce the cost of the maintenance. Reasons one is applicable diagnostics only targeted to monitor the diagnostic information from the smart field instruments. And then at the other side, the equipment health. The equipment also one of the asset, but the major difference between the asset management and equipment health. In equipment health, we are only concentrating on the rotating equipments like turbines, and pumps. Those are all the assets health. There are remote diagnostic service, those are the we will analyze the data that we are collected from the solutions or any recommended maintenance activities to improve the reliability of the particular equipment. And then the work management, we have two solutions. One is shift management and web BFS, which is mainly to manage the balance between the operations and maintenance workflow to ensure that the proper workload between the operations and maintenance team. And then let's go what is from any cyber attack.
Hi, Sir JP. Sorry for the interruption again,
Uh,
but
all
you're still having bad audio. I think we totally lost you. So I think we lost our speaker. Maybe he's really having internet connection issues.
no, actually,
So
I'm here.
you're here. Sir, can we interrupt you for like a couple of minutes? Can you, if you don't mind, can you please double check your like internet connection or audio so that um
Okay, let me check
our,
it again.
yes, so that our participants can understand you better?
Sorry, I haven't faced any issue because I'm having 500 Mbps internet and
Mm-hmm.
daily I'm connecting to the office because I'm working remotely, work from home. I don't have any issues previously. Unfortunately, right now I'm having some issues.
Are you using your Bluetooth speaker or?
No, I'm using my headset, which is directly
Headset?
connected to the laptop.
Mhm. Do you have any other internet provider that we can try so that um our participants can understand the presentation? Because the audio keeps on cutting off earlier. And we really apologize for the several interruptions that we have made, but a lot of our participants
But
are
just now
then.
I know. Just now I noticed I was unmuted. Have you
Mhm.
unmuted or now? When you interrupt me, that time I noticed I was unmuted. So I mute myself and speaking now. I don't know whether it is automatically unmuting. Yeah, I got a message that it's unstable connection, not bad connection. I don't know why.
Okay. Well, we'll just Sir JP, can we just take a few minute break? So you can also double check your internet connection, and you can also double check our technical difficulties on our end. So we'll have a few minutes break. Would that be okay, Sir JP?
Yes, okay.
Okay. Thank you so
Another
much. We'll
band.
let you know, sir, if we're going to be back on our session for your technical presentation.
Yeah.
Yes, sir. Thank you so much, sir. We'll let you know right away.
For IoT and Industry 4.0 data visualization applications, monitors serve as crucial information display devices in manufacturing sites and factories. But how do you select the right monitor? Many people choose commercial monitors because of their low price. However, commercial monitors are built for office and retail environments. They are not designed to withstand operation in harsh industrial settings that involve constant vibration, temperature and power fluctuations, humidity, dirt, dust, and high usage rates. When monitors fail in industrial environments, the entire process is interrupted while the monitor is replaced or repaired. The resulting system downtime reduces productivity and overall revenue. Secondly, in terms of cost of ownership over time, the lifespan of industrial monitors is typically 3 times that of commercial monitors. Thus, in the long run, the cost of ownership over time for industrial monitors is actually less, even though the initial purchase cost is higher. Finally, for industrial field applications, monitors must support long-term usage. Unlike commercial monitors that change on a yearly basis, industrial monitors provides model consistency and long-term availability. We hope that by watching this video, you have the knowledge to make a wise choice. Advantech's FPM series industrial monitors are rugged, reliable, and easy to use, delivering world-class quality you can rely on.
The additive manufacturing process enables us to manufacture parts that we cannot manufacture today with normal, traditional manufacturing processes. That enables us to be more ingenious in terms of how we design our turbine blades, how we cool them and how we life them.
Turbine blades has always been, I feel like, a vision. It's a real target. It's the most challenging area of the turbine. So if you can print a turbine blade, you can pretty much print anything. And we've proven over the last couple of weeks now that we have been able to print a turbine blade and test it in an industrial gas turbine engine.
In Lincoln, we're testing a 3D printed plate, and we believe this is special because it's the first time anywhere in the world this has been tested at full load conditions in a gas turbine. We test these blades very quickly. In 1 hour, we run the engine at full load. We put a probe in here to measure the material temperatures, which tell us how long these blades will last in a turbine.
Now, the turbine blade itself is this particular blade. Now, this is the high pressure turbine blade of a 13 megawatt SGT 400. Typically, we have to do all of the design, analysis, the aerodynamics, the work in terms of heat transfer on this blade 2 years before we can actually then understand in an engine how it's actually going to perform. What additive manufacture does, and this is the additive manufacture blade that we've actually tested in this engine, this gives us the ability to cut that lead time down from 2 years down to 2 months.
It allows us to create new designs, to get more efficient engines, more efficient designs into our turbines, tested and then onto ultimately our customers.
We will see quicker development times.
You don't need this very expensive tooling in order to make your products. So that makes additive manufacturing perfect for design modifications. You'll get there much quicker.
The basic process starts with receiving the model from the customer. We'll then take that model and slice it into very thin layers and export it to the machine. The machine then builds it up in a very thin layers, 20 microns, using a laser to melt all of the metal powder together to create the final product. Although we've been developing the technology for 10 years, we're still very much at the beginning of the journey of what this technology is capable of. To a certain extent, if you can design it, we can make it.
None of this would have happened without the tremendously close collaboration between a large number of Siemens units. It really is ingenuity for life to enable us to satisfy all of our customer needs.
Manufacturers today are seeking efficiencies in production and ways to transform their business through Industry 4.0. Advantech offers intelligent factory solutions designed to help customers unlock the potential of data acquisition, data computing, data visualization, and centralized management in order to create their own smart factories while also improving productivity, reducing loss, and increasing profits. Advantech's solutions include an overall equipment effectiveness solution and a factory energy management solution. The OEE solution utilizes real-time machine management for maximizing operational excellence. The FEM solution enables centralized monitoring and data management for optimizing energy efficiency. For these solutions, customers can use Advantech's on-site servers or cloud platform. The solution features support KPI management, alarm notifications, and remote access to dashboards for convenient management. Moreover, the provision of data visualization and real-time dashboards in the Industry 4.0 Situation Room allows managers to make efficient, data-driven decisions. Join us and unlock the potential of Industry 4.0.
メトロは現在10路線133駅、総延長 137.8 キロ、1日平均約250万人のお客様にご利用いただいているところでございます。2018年4月に大阪メトロとしてスタートいたしましたが、安全確保につきましては鉄道事業者として絶対的使命であることには変わりありません。 駅スタッフによる見守り業務を実施するにあたり、連携ツールといたしまして、3カ年計画で、大阪メトロ133駅全駅に552台を配備いたしました。トランシーバーはホームのようにまっすぐで見通せる区間でありましたら有効活用できるんですが、我々地下空間という特殊な空間がネックとなりまして、すぐ近くにもかかわらず、上下の階層ですとかでしたらつながらないっていう状況がありました。IP 無線機は通常の携帯電話回線と同様に使用できるため、地下の駅構内でも通信エリアが格段に広がったと、あと、雑音なども入らずにクリアに聞けるということで効果があったと考えております。またIP 無線機による通信内容を複数の駅スタッフで共有できることから、連絡ミスや、ヒューマンエラーの防止に効果があると考えられております。
難波駅は御堂筋線、四ツ橋線、千日前線の3線が入った大阪メトロで2番目に大きな駅です。電話のように通信できるのと振り込み通話ができるので、お客様の案内にも役立っております。やはり素早く安心丁寧にということは一番大事だと思いますので、会場を受けてもらったらすぐに連絡をすることで迅速に対応することを心がけています。操作はボタンを押すだけで喋ることができて、音声もクリアに聞こえますので、素早い対応ができるようになりましたので、お客様満足にもつながっていると思います。
駅業務の利用実績が各部署に伝わりまして、運転部門では運転士と車掌並びに指令書の係員間で用いること、また車両部門に関しましては検車場内で検車係員間の連絡ツールとして IP 無線機が活用できるか各部署で検討しているところでございます。
Siemens Energy is offering under the 7 different digital services. The first one.
So JP, sorry to interrupt you. I hope for the last time, but can we request to make the presentation in full screen?
Actually, I'm not sharing my screen. Nobody's sharing.
Noble. Sir Noble, can we request? Yes, right now it's on full screen, but can we skip to the 11th slide so that Sir JP can resume his talk? That's it. Thank you so much, Sir Noble and Sir JP. You can now proceed on resuming your talk.
Okay, thank you. So, mainly to extend asset life and reduce the cost of the maintenance. The asset management solution is, we call it as asset performance management solution that is dedicatedly designed for power plants on oil and gas. And further, we have a special asset diagnostic solutions for the field instruments, which are smart field instruments. The most widely used communication protocol like foundation field bus, Profibus, and hot-based communication-based assets. And then the equipment health, we have different solutions. The basic difference between the asset management and equipment health is equipment health, we are concentrating on the bigger rotating equipments like steam turbines, pumps, the generators, and those are the assets which are part of the equipment health solutions. For instance, like a remote diagnostics service under equipment health will provide the diagnostic solutions for the steam turbine which is running inside the plant. Our solution will be deployed at the site to collect the diagnostic information and then send it to our data center. Our data center will be having some machine learning and AI algorithm-based engines which will analyze the data received from the site. So we will talk about that particular solution in detail, but I'm just giving a glimpse about what are the different solutions under each services. If you take the work management, we'll be having two different services, which is mainly to balance the workflows between the maintenance and operation team, so that we'll have a centralized work management in order to track the work initiated for the particular maintenance activity. Nabil, can you move to the next slide? Yeah. The other three services, what is cybersecurity and remote services and operation excellence sustainability services, are the services which is also part of our Omniwise services. What is cybersecurity? I'm going to talk about in detail. I'm having a separate high-level walkthrough about the cybersecurity solution. And the remote services, this is the highly demanded solutions as of now because of the COVID restrictions. Usually our site engineer will go to the site and perform the maintenance activities and to support the on-site technicians to perform the maintenance. But due to the restrictions, our guys cannot able to travel, and then this remote O&M support service really help for the time. Our remote service engineer will log into the system and see that and perform some remote diagnostic activity and see the logs collected from the system as part of their maintenance activities. So, Nabil, can you move to the next slide? Next one. Yeah. So far we have given an overview of different solutions and the different Omniwise digital portfolio. I just want to give an idea of one particular solution so that you will see what are the benefits that the customer can get from this solution. The solution I'm going to talk about is the remote diagnostic service, which is coming under equipment health solution. So what we are going to do is collect the data from the particular equipment like gas turbine or any other pump or motor, and then we will perform the diagnostic analysis. We built our own engine based on the latest technologies, like based on the machine learning and AI algorithms, so that the data which are collected from the plant will be fed into this system, and then the system will provide the recommendations to the customers to perform their maintenance activities. So this is just to optimize the asset protection by turning the data into the values. We are turning the data into the values using the different technologies in this remote diagnostic solution. Can you move to the next slide? This is just given an idea of how the data is transmitted to our data center, where our engine is running to analyze the data. Basically, the customer site will be having equipments, which may be a rotating equipment like compressors or steam turbines. Those equipments already running at the plant, and we'll be having our edge device, we call it as a data collector, which will be installed at the system level, which will be communicating to the equipment to collect the real-time data and pass the data to our data center. So the connectivity from the plant to our Siemens data center is through the internet, but we'll be having a high secured mechanism or high security solutions that ensure the secured VPN connection established between the site to the plant to ensure the data is to maintain the data integrity and other any other cybersecurity concerns raised during the integrating the data. So, Noble, can you go to the next slide? Under the remote diagnostic services, there are, as I mentioned, we are mainly concentrating on the rotating equipment in the power and gas industries, such as turbines, compressor and pumps and motors. So these are the equipments which are the heart of the plant. So the equipments need to be maintained well in order to avoid any unwanted disruption. So once this data is collected from the plant and analyzed by our engineer, on the other hand, the operator or the asset owner will be given an additional access to monitor the performance of the particular equipment. They can also see the real-time data from their mobile application itself. So, it also, apart from analyzing the data, it will also give an additional data, means additional assessing of the data to know what is happening in terms of performance of the particular equipment. So this is one of the main solution that we are offering under equipment health service portfolio. Okay, Noble, can you go to the next slide? Okay, I'm going, before moving to the cybersecurity portion, I pause here for any questions. Okay, let's move to the operational technology cybersecurity. Here we are going to discuss about what is operational technology, how it differentiates from the IT, what are all the risks involved in cyber industrial digital transformations, how Siemens Energy is helping the customers to reduce the risk in integrating those systems. So before we go to the OT cybersecurity, I want to give an overview of the difference between the OT and IT cybersecurity. In operation technology, we are talking about the systems which are controlling or monitoring the machines, equipment used in the operational environment. It may be in the manufacturing industry or any other power generation or oil and gas industry. Whereas the IT systems are used to collect for the business purpose in terms of providing the infrastructure to the employees and collecting the data from the OT to do some data processing and analytics. So there are major difference between the IT and OT is if you are into the cybersecurity, we call this a CAA pyramid. Pyramid is integrity, confidentiality, and availability. In terms of the OT cybersecurity, the availability and safety is more important than the confidentiality. Whereas in the IT system, the confidentiality is given more priority. The lifetime of the IT systems about 3 to 5 years. Every 3 to 5 years, the company IT will refresh their assets so that the new system will be introduced without any disruptions to the plant. Whereas in the operational technology, we are having the assets which are legacy. Even nowadays, we are having a Windows 2000 or Windows XP is running on some plant. Mainly because of they don't want to stop the plant because of to migrate the system to the latest systems. So the biggest difficulty is the leveraging the lifetime of the particular component, and also it cannot be easily migrated, whereas in IT is around the system, but whereas in OT that is not possible. Okay, Noble, can you go to the next slide? Okay, so by doing the digital transformation, we are having some challenges. The challenges is because of the blind spots available in the operational technology. The blind spots I mean here is the things are available, but we are not giving enough priority to those particular information or particular systems inside the operational technology. For example, the lack of visibility into the assets. In operation technology, we are not having any proper tools to know what are all the assets connected to the particular control system. So without knowing what are the system or what are the assets being connected, we could not develop any cybersecurity plan. Otherwise, it will be applied to only the systems it is detected. So the lack of visibility is one of the blind spot, and then lack of response plan. For example, if any incident happens, how we can recover, what is our business continuity plan and recovery system, and also lack of knowledge or training to the people on the system. So these are the blind spots that gives high challenges in the digital transformation. Because of we need to address those blind spots by having a proper roadmap and proper cybersecurity solution to address those issues. Noble, can you move to next slide? No, just before. One slide up. Noble, one slide before. Yeah. Here I'm going to talk about the attack surface. The attack surface is kind of in system resources like the software or the computer that you are having the operational environment, which having some vulnerabilities which can be exploited by an attacker to compromise the system. So those are the vulnerabilities available inside the system that makes the attack surface bigger. In a cyber resilient design or system, those attack surface to be minimized with the proper implementation of the solution. For example, if you have an unpatched or misconfigured system inside our operational technology, that gives an additional attack surface to the environment where the attacker can usually exploit the vulnerabilities available on the particular system, and then using that system they can do whatever they want. In fact, they can stop the entire plant operation. They can do any HSC related incident also to the plant. So those are the things which eventually increases the possibility of the attack to your plant when you are moving towards digitalization. The other thing is now we are in the 5G and IIoT. There are a lot of devices which is part of the operational technology environment, which also increases the attack surfaces, which also gives an additional advantage to the attacker. So these are the things we need to consider before when we go for the particular digital transformation. We need to do some proper analysis of the attack surfaces that being introduced by the new technology or new system that need to be properly assessed and properly mitigated in a cybersecurity solution. Noble, can you go next slide? Hello, Noble. Can you move to the next? Yeah, correct. So this slide, I'm just providing some statistics information about how attackers are growing deliberately and sophisticated because of the latest technologies and tools available with them to target the utilities or any industries. They can develop some viruses or malwares and ask for some ransom in order to release the asset to the operations. So the technology also coming up, the hacker also having a sophisticated tool to exploit the vulnerabilities available in the system. So the above statistics will give you an idea about 25% of the report being impacted by the national state mega attacks. And then there are 54% of the attack on the critical infrastructure, especially on the power plants within 12 months. So every 12 months, the attack happen. If you take the statistics, they are targeting on the critical infrastructure because the critical infrastructure will give more ransom or to meet their agenda. So the high statistics is the critical infrastructure are the main target for the attackers. Okay. Go to the next slide, Honorable. Next one. Yeah, having seen all these risks and the attackers' agenda in attacking the critical infrastructures, Siemens Energy has dedicated cybersecurity services under Omniwise. We have Omniwise cybersecurity solutions, especially for the operational technology environment. So here are our standard cybersecurity portfolio. We have divided into 5 categories just to match with the international standards and regulatory requirements, where we'll be having solutions and coming under identify, protect, detect, respond, and recover. So the identify is just to give an assessment to the environment, how the maturity level reached in terms of cybersecurity for the particular plant. We'll be doing some gap assessment. What are all the key critical cybersecurity solutions that are missing to meet the cybersecurity regulatory requirement? Those kind of assessments we will be doing under our identify verticals, and we have 2 different solutions based on the customer requirement. While on the product side, we have different solutions. It's kind of one solution for entire operation technology systems like asset management. As I mentioned, there are some blind spots in terms of discovering the assets that are being connected in the particular plant. Our asset management solution will give you a holistic view of all the assets which are connected, which are even if they connect a new asset, it will detect the assets. Even with the different protocols, it can have the capability to detect those assets. On the product side, we also having vulnerability management system. Those vulnerability management solution will provide an vulnerability which are currently present on the assets that are deployed in the plant. So we have different solutions to meet the customer requirements. I mean, these are the solutions will be deployed based on the assessment that we do at the identify stage. At the top, on the top of the product, we also have some detection system which will detect any anomaly detections, any intrusion happen from outside to the plant by analyzing the traffic that is coming in and out to the plant. For example, the solution we talked about before, the RDS solution, the remote diagnostic solution, where we send out the data from the plant to the our Siemens diagnostic center. Though we are having a secure VPN connection between the system, that particular solution or service will give one layer of security, but having this anomaly detection or NIDS solution at that place will monitor all the communication between the systems. If it detects any anomaly communication that is happening between the system, then it will report the particular anomaly. And then the respond recover is kind of an tabletop exercise to the customer, how the asset owner can respond if any incident happens at their plant. So we'll be guiding them to create a disaster recovery plan, also testing of the incident response planning. Noble, can you go to the next slide? Hello. Yep, this slide is just to insert, and we want to differentiate what are all the solutions that is applicable for our system and what are the solutions that we are going for a multi-vendor approach. So in a given operational environment, if you go to any industry, there is a possibility of different systems from different OEMs. So we are having the solution that also fits to the different vendors. So this solution we call this as a vendor agnostic solution. So the solution can be deployed for other OEM systems as well. Can you go to the next slide? Noble? Yeah. So when we go to a customer and do the assessment, we usually provide recommendations, and in the recommendation we package the solutions to meet the customer's requirement. So all the solutions maybe the customer don't want to install, but there are some solutions that the plant or the particular system should have. We call it as a basic solution, and then we have another package as a essential, which is also a recommended solution, and then essential plus. So these are the solutions will be deployed, and it forms the different layer of the security. So the basic is the core component of your cybersecurity control, and then on the top of it, the essential solution will be deployed, and then essential plus solutions also be deployed. So when any of the main advantage of this different layer of packaging of different layer of security is to ensure that if any of the layer of the security fails, the another layer of the security comes in to protect your environment. So the basic solution we package it as a bare minimum solutions, like the patch management, like Windows or any application patch management, and then antivirus and anti-malware solution with the McAfee or any other product. And then the application whitelisting is the solution to monitor what are all the different applications that are need to be allowed to run on the particular system. So that forms the basic solution. On the top of it, we'll be having essential package. As essential package, we'll be having vulnerability management solution, security event monitoring. Security event monitoring is to collect the logs generated from the systems, from various operating system, various switches, that will be sent to next level of analyzing that is called as SIEM, security information event monitoring. So that coming under the essential package, and then the essential plus will be having the vulnerability management and some optional packages like regularity assessments also coming under our cybersecurity solution packages. Noble, can you go to the next slide? Okay, how we are about the time, because it's almost, we are at the end of the time. The upcoming slide is to just to give an overview of the each solution that we are offering. Jacqueline, are we okay with the time?
I think we have a few minutes left, so I suggest we can try to wrap up, okay, in 2 to 3 minutes and provide them the contact details.
Okay, let me know if we have any questions before.
Hi, Sir JP. I think we have few questions coming from our participants. Do you want to answer them now, or do you want to wrap up your discussion first, and then we'll proceed with the Q&A session?
Yeah, considering that maybe I can address those questions later, since we have 3 minutes left this presentation.
No problem, sir. We'll cater maybe around 2 to 3 questions, and then the remaining questions you can just provide your contact details, so then the participants can reach them out or can ask you questions.
Okay.
Okay, thank you so much, JP. You may now resume your discussion and wrap your technical session. Thank you so much, JP.
Noble, can you go to the last slide, the contact details? Okay, please note this slide for the contact details. You can reach to either Noble or our sales head, who is Max Martinet, who is unfortunately not able to join this call. But if you have any questions related to the cyber digital transformations and cybersecurity, please reach to us. We'll be happy to support you all. Okay. Thanks again for this opportunity, and apologies from my side not being able to properly explain you because of some communication issue. I thought the last section will be clear and loud to us all.
Yes, Sir JP, the audio became better when Sir Nobel started sharing a screen on his side. So let me just reshare my screen. Okay, so once again, on behalf of IECEP Incorporated, we would like to extend our gratitude to Mr. Jayaprakash JP Velayshami for having an in-depth discussion about industrial digital transformation. And like what I've mentioned, Sir JP, we can cater around 2 questions, and then we'll just disseminate your contact information to the participants, so that if they have, in case, some questions that they wanted to ask you, and due to time constraints, we can't cater them anymore, so they can reach out through your contact details. So we have here some questions that came from our participants. Would it be okay, Sir JP, if you cater 2 questions?
Yes. Sure.
Okay. So the first question, PSA network connected to PCS network or DCS system. What is your architecture in terms of cybersecurity requirements connecting these 2 network systems?
Yeah, basically we will be doing our assessment in connecting the PCS system to a PSA network system, and we'll do some assessment, and based on the standard that need to be followed, and what are the solutions that need to be deployed. That will be under our assessment portfolio. So basically we will be doing some assessments, and we will recommend you the proper architecture. We call it as a zone and conduit, and follows the IEC 62443 podium model level. I hope this answer question. Anyhow, if you feel it is not the correct answer, maybe we can discuss it offline to understand you better.
Yes, sir, no problem. And then another question. Yes, and for the next question, this is from the from an anonymous attendee. In the Omnivise solution for equipment health, is condition monitoring and protection for equipment software based alone or a combination of software and hardware, and can it be customized?
It's a good question, actually. I appreciate this question. Our solution is a combination of hardware and software, and also it can be customized based on the requirement as well. So that is our answer to this question. If you require any further detail in regards to this equipment health, please feel free to reach with us. We can help you. Okay.
So once again, thank you so much, Mr. Jayaprakash Velayshami, for that very or highly relevant and well discussed topic about the discussion that you made earlier. So I think due to time constraints, this would be the last question that we'll entertain. And like what Mr. JP have mentioned earlier, you can contact them through the email address and the contact number that they've provided earlier if you have further questions about or regarding the topic. So we'll now proceed with the awarding of the plaque of appreciation to our well-regarded resource speaker, Mr. Jayaprakash Velayshami. I would want you to stay on the spotlight as we present to you this plaque of appreciation. The plaque of appreciation will be awarded by Engineer Donna Angeline C. Valdez, the current IECEP Mindoro Governor.
Good evening, everyone. It is my honor to award the Certificate of Appreciation to our very committed speaker tonight on industrial digital transformation. Allow me to read it for you, sir. Institute of Electronics Engineers of the Philippines Incorporated awards this plaque of appreciation to Mr. Jayaprakash J.P. Vilekami in grateful recognition of his expertise, professional competence, and invaluable service rendered as a resource speaker during the 71st Annual General Membership Meeting and Convention, with a theme embracing digital transformation in the time of new normal. Given this 29th of November 2021, this is signed by Dr. Lori Lisa D. Villarreal, PSCE, our e-AGM 2021 Convention Chairman and Secretary General, and our President, Dr. Michelle D. Lawas, PECE. Again, congratulations and invaluable service rendered as a resource.
Thank you very much for your appreciation. I'll be very grateful to you. Yep.
With a theme embracing digital transformation in the time of new normal.
We will be also forever grateful to you, Mr. Jayaprakash Velayshami, because despite of all the technical difficulties earlier, you were able to really still share your knowledge about the topic that you've discussed earlier. Once again, on behalf of IECEP Incorporated, we would like to extend our gratitude to Mr. Jayaprakash J.P. Velayshami. I hope we get to invite you, sir, once more or some other time whenever we need some resource speaker for our event. Thank you so much, Sir JP.
Thank you very much. It's been a great pleasure for me to participate in this event. I'm looking for in future also. Thanks again.
Thank you so much. Difficulties earlier, you were able to and really now share your knowledge along. It is now time to have our second technical once again on behalf of IECEP Incorporated, would like to introduce our 8th resource speaker in our 8th I hope we get to invite you in this year's once more or some of us have Engineer Favis Joseph C. Balinado. while we are still waiting for Engineer Favis Joseph Balinado to introduce our second technical speaker for the day, let me just remind you to do not forget to fill out the attendance and evaluation link. The link are already posted in the chat box, because this will serve as your or as our basis to give you the CPD points for the corresponding CPD points for this e-AGM 2.0. Nasaan yung yung credentials? Wala akong copy. Kay Jaya Prakash yung nandun sa Okay, so I think you've heard me talking about something earlier, and I apologize for that. And while we are still waiting for Engineer Favis Joseph C. Balinado to introduce our resource speaker, once again, this event, our e-AGM 2.0, would not have been possible without the initiatives and commitment of all the hardworking committees working incessantly and tirelessly behind the scenes. And of course, we would also like to acknowledge our sponsors who are instrumental in the conduct of this event. Wireless Link Technologies, AWS Distribution Philippines Corporation, Siemens Energy, Advanced Tech Corporation Malaysia and AMPI, United Electrical Specialists Incorporated, PT Cerna Corporation, Excel First Review and Training Center, Allied, Telesis Philippines Incorporated, Panasonic Business, Infinite Care Technology Solutions, Stig State Power. Once again, on behalf of IECEP Incorporated, we would like to extend our gratitude for sponsoring this event. And of course, do not forget to like our official Facebook page. It is at IECEP National Official to get updated on the future announcements and events. And also, aside from the session here on Zoom, you can also watch our live stream on YouTube. You can subscribe at IECEP National on YouTube. And of course, do not forget to subscribe and click on the notification bell to get notified at all times. And since I think Engineer Favis is having some difficulties on his end, I will just introduce to you our next speaker. He is a licensed electrical engineer and currently working as a senior PLC engineer at Philippines Innorev Automation Incorporated. He specializes on automation applications catering to residential, commercial, and industrial fields. He has a substantial knowledge, skills, and expertise in programming, testing, and commissioning projects such as manufacturing control systems, SCADA, water and wastewater systems, HVAC systems, BTU metering, and most especially products such as RTU, PLC, microcontrollers, servo and stepper motors, sensors such as temperature, humidity, pressure, water level, sensors, BTU meters, heat valves, actuators, radio modems, and electricity water meters. He is currently working as a business development manager to Advanced Tech Philippines and a sales application engineer to their channel partner Accent Micro Technologies. Without further ado, let us all welcome our second technical resource speaker for today, And of course, our 8th resource speaker during our 8th-day event, e-AGM 2.0. Let us all welcome Engineer Aaron Lennin G. Javier.
Thank you, Ma'am Jacqueline. Yan
Thank
na
you
rin.
so much.
Can everyone hear me?
Yes, sir.
Yan, okay. Good evening po sa lahat. So let me just try if I can share my screen. Okay, can everyone see my screen?
Yes, sir. We can now see your screen.
Okay, so I guess we can start. But let me just unshare again. How to unshare? Pause share. Okay.
Stop share. Yes.
Okay. So let's start. Thank you, Ma'am Jacqueline, for introducing me. So before we start, I'd like to say good evening to everyone, to our honorary IECEP Board of Directors and Governors, our distinguished guests from Accent Microtechnologies, led by Sir Lawrence Chan, Senior Vice President, from our Advantech Malaysian team, led by Sir Elvin Nang, ASEAN IIoT Sector Head. Special mention to Ms. LM and Nabila from Inside Sales and Marketing Department of Advantech, and our partners from Global Tech Automation, one of our system integrator partners, implementing IIoT products and solutions here in the Philippines, led by Sir Leo Santos, Company President. And of course, the electronics and communication engineering professionals attending these technical sessions. To all, thank you so much for attending this session. So before I start my presentation, let me discuss why did I select this specific topic. As you may all know, we are already at the Industry 4.0. It has made a huge impact on the digital transformations from the way we acquire the data up to how we process it. New technologies, bridging IT and OT systems are now prevalent in the market without having the need of some middleware products and devices just to link the two systems. And with that, we cannot disregard the importance of the existing and current systems that are still widely used in the automation industry. One such thing is the Modbus protocol, which is one of the oldest open protocol, a simple data representation of master and slave transaction, and is widely used protocol in connecting electronic devices. For the duration of the topic, you will get a basic to advanced discussion of the Modbus protocol and its applications. I intended this topic to new electronics and communication engineer professionals who would like to explore the automation industry career. I believe that Modbus protocol introduction is a good way to open up the opportunity for you to learn the automation world. Okay, so for existing professionals as well, who are planning to implement industrial IoT projects within your companies, let's say you are in the transportation solutions or in manufacturing solutions, SMT lines, or even in food and beverage, and you would like to develop an what they call this, like an automation or monitoring system, then this topic is definitely for you. Okay, so
Hi,
with
Sir Engineer Javier.
Yes?
Sorry to interrupt. But are you trying to share for your PowerPoint presentation?
Not yet, Papa.
Not yet.
Pa.
Okay.
Yeah.
Sorry,
Okay.
sir. You may
So,
continue. Thank you
okay.
so much.
Sure. No worries. Okay. So with that, sakto po, Ma'am Jacqueline. So with that, I now present you as let me see if I can share my screen. Ma'am Jacqueline, can you check if I've already shared my screen?
Yes, sir. You're
Okay.
now sharing your presentation.
Oh yeah, presentation. Okay, so with that, I now present to you as brought to us by Advantech and its channel partner Amarantos AMTI, our technical session topic titled Data Acquisition Through Modbus Communication Protocol. I am Engineer Aaron Javier, REE, from Advantech AMTI, acting as Business Development Manager for Advantech Philippines and as Sales and Application Engineer under our channel partner, AMTI. Okay, so let's start. Okay,
Do let me know within the session if you have any difficulty or any issues on the communications or on the audio. Just feel free to interrupt me. I may have difficulty checking some of your questions. As I only have one screen available right now, so I cannot multitask. But later I will try to give some time to answer all of those questions after, or maybe in the middle of my presentations. Okay, so let's start. Let's start first. So let's start first what for the topic. The first thing that we're going to tackle is what is Modbus, its definition and history, as well as its comparison with other automation protocols. We will also be looking at just a brief overview of its data structure. Okay. Next one would be a topic about Modbus registers. Different manufacturers so that we can interpret and implement how, or apply what we have learned from these past few topics that we are going to discuss later. Okay, and then on the third one is the network topology of Modbus RTU and the Modbus TCP IP. What is the difference? What is the advantages? We will tackle everything on the network topology topic. And for the last part is an application and case study, some sample system architecture of our projects that have already been implemented in the Southeast Asian regions, courtesy by Advantech, and also local projects that we are applying currently here, locally here in the Philippines. So more on that later on the last part of our presentation. Okay, so let's proceed with the first topic. So what is Modbus? Oh, sorry. For the references, my references came from Simply Modbus website at www.simplymodbus.ca, and also from the official Modbus organization website at www.modbus.org. Also, some topics related here came from our Advantech IIoT Academy at academy.advantech.com. So later, I'll give you more information. What is this Advantech IIoT Academy? Okay. Okay, so what is Modbus? Its history and definition. History. So Modbus is a serial communication protocol developed by Modicon in 1979 for their programmable logic controllers. With the during the 90s, with the popularity of the Ethernet TCP/IP, Modbus TCP was implemented in 1999 to cope up with the emerging technology. Okay, so despite having Modbus under Modicon and now under Schneider Electric, Modbus is an open protocol, meaning third-party products or other brands, other manufacturers like instrumentation manufacturers or other PLC manufacturers such as Siemens, Omron, Advantech, Allen Bradley, they can still use a Modbus protocol without having to pay any royalties, as long as they follow the standard Modbus as defined by the Modbus organization. So Modbus is a messaging structure developed to transmit information between master and slave intelligent devices over buses or networks. If you take a look at the OSI model, you will find that Modbus is under the application layer of the OSI model, but not onto that. We're not onto that. Okay, so in a standard Modbus network, there is one master and up to 247 slave addresses, each with a unique slave address from 1 to 247. Modbus topology exists either through serial or Ethernet. For serial, the Modbus is for serial communication, we use the term Modbus RTU. And for Ethernet-based Modbus communication, we are using Modbus TCP. Okay. To have an overview of the Modbus application in the automation world, let us refer to the automation pyramid. Okay. So most of you might be familiar with this one, but this serves as a reference of where your system or your hardware falls under the automation pyramid. On the topmost, we have the management or our enterprises, our enterprise system. Under the planning level, under that is the planning level, which is usually our MES system, or the, if I'm correct, that is the manufacturing execution systems. Below that is the supervisory, which is the in which SCADA and HMI takes place or is belonged. Below that is the control level. So as you can see, there's a lot of listed PLC controllers here, ranging from our programmable logic controllers. We also have our distributed control systems. We also have those BMS controllers, such as the DDC controller, direct digital controller, if I'm correct. And then the PAC, which is a programmable automation computers. And on the field level is the sensor actuators. Okay, so let's zoom out again. So when it comes to who handles which, from the management level down to the supervisory, IT is involved, or the information technology personnel are involved on that. Okay, while on the operational technology, that is from the SCADA, sharing some resources with the IT, down to the field level. Okay, so let's have some examples of the systems and protocols being used. For the management, let's see, let's try to zoom in a little bit. Sana walang maputol. Okay. For management, ERP management level, some of the most popular ERP systems are from SAP and Oracle. For planning, I believe SAP also has an MES system, but my example right here is the Wonderware MES software operations. Under the supervisory, we have our own, I put here our example, which is our Advantech Web Access SCADA. This is a browser-based SCADA, alongside with a different SCADA manufacturer, which is the Ignition SCADA. I believe this is also a dashboard-style web-based SCADA system. But correct me if I'm wrong, I'm not actually on the Ignition side. I'm more on the Advantech products, okay? And then, so where does Modbus comes in? Okay, pretty much if it is under the OT or operational technology, this is where all this communication protocols comes in. So as you can see here, I did put some sample automation protocols. We have OPC-UA, we have EtherCAT, we have Modbus, we have DNP3. We have more than that. On the next slide, I will give you some overview of some of the popular protocols. Okay, but for now, this is just some of my examples. So we have here the Modbus. It pretty much Modbus pretty much exists in SCADA implementation, in PLC, and even data acquisition from our sensors and actuators. Okay. Especially noted for the, I would like to pinpoint specifically for the OPC-UA. OPC-UA, it has more when it comes to cross-level interaction with IT and what do you call this? Stay under the OT system, but they can also integrate to other IT systems as well. So OPC is quite versatile, not unlike Modbus. So Modbus, okay, Modbus, okay, you will not see an IT guy. Hey, can you give me the temperature reading of that machine through Modbus, and I directly connect that to our Oracle database or to our MES system? It's not like that. So there's several systems or software and even hardware for it to go through that specific IT system. Okay, so Modbus, again, it usually lies under the OT side of the automation pyramid. Okay, so so with that, if Modbus is within this is on the lower level of the automation pyramid, Modbus and these other protocols as well will have from the field level will have the data will what they call this will handle the data acquisition and transformation of our field devices, sensors and actuators. It is the conversion of the raw values into engineering values. So when I say raw values, it can either be this digital signal or an analog signal or discrete signals. They are data, but in the engineering level, we cannot utilize that data as of now. It's raw, okay? It's raw. We still had to convert it to something else. So this process takes place on the OT side, okay? So the process of converting this raw value onto engineering value that we can utilize. And talking about the signals, okay, most of you are quite familiar here, but for those who are just entering the professional world, okay, so for the signals, okay, we have here the analog and discrete signals. First, we have the analog that is usually represented in voltage, current, and resistance. For voltage, most common is 0 to 10 volts or 0 to 5 volts DC. Such instruments are for like valve actuators to manually open the valve. Or sorry, to vary the opening of the valve, you'll have to vary the voltage from 0 to 10 volts. Okay, so that's for the application of analog voltage sensors or actuators. For current, we have 4 to 20 milliamps or negative 20 milliamps to positive 20 milliamps. So this is predominantly used in some transducers, for example, humidity sensors, pressure transducers, and things like that, similar to those products. Okay, and the third one is resistance. Usually, we just encounter these two types of temperature sensors, whether if it is a thermocouple or an RTD. So for this example, as you can see here, I have a PT100 sensor with an analog value. So this analog value is a resistance. Okay, second is the discrete. Simply, it's an on and off signal. On and off, but you can categorize this on and off whether if it is a dry or a wet contact. Dry meaning there's no voltage between the two wires. Okay, we are just our device is just detecting the continuity of the wire. Okay, so the continuity of the wire. And for wet contact, that means there's a potential voltage between the two wires. So interpreted as 0 meaning off and 5 volts as on. But it varies from manufacturer to manufacturer. One example that I put here is the photoelectric sensor that is used in manufacturing to detect the presence of, usually to detect the presence of a product. Okay, you can imagine a conveyor belt line having some integrated chips, and you would like to detect how you would like to count those IC chips passing through the specific machine. You can use a photoelectric sensor to detect those things, whether counter or the presence. Okay, now analog and discrete are electrical properties, right? Voltage is an electrical property, current is an electrical property, and as well as resistance. And discrete, on off, dry or wet contact, these are electrical property. We still cannot process this data and send it to the PLC directly. If you can imagine, you are going to program a PLC, like if the value of the temperature is negative 10.05 volts, it doesn't make sense, right? Why are you going to represent the temperature in terms of voltage when you are programming? That's why we have to convert this data into digital signals. And this is where I/O module comes in. So what on my example here, the analog and discrete signals are connected this to this. On my example is one of our product, which is the Adam IO module. So what it does is this is an IO module that accepts it accepts analog input and controls analog output devices or digital output. Okay, and for analog input, it transforms these data into digital signals for our PLC to interpret these data into engineering values. You may notice that on the last part, we have a digital signal. So this digital signal, on my example, is an ultrasonic flow meters. We refer to it, we refer to these devices as smart or intelligent devices. Why do we refer to it as smart devices? First of all, in analog, let's go back to the analog. For this PT100 sensors, this device can only send you the temperature. That's it. For the photoelectric sensor, it can only give you the presence. No device, there is device, on and off, right? But for digital signal, you can get a lot from a specific product that has a digital signal capability. Smart devices. So not only the flow rate, you can also get the accumulated volume. You can, if this is a battery powered, you can get the battery level. You can set remotely the specific set points and parameters. View the parameters. What else? For ultrasonic flow meters, you can also have accumulated data. Yeah, I believe I already mentioned that. But you get, I hope you got the point, right? You can get more out of these smart devices, and directly you can send that to your PLC, or in this case, we have an Advantech RTU to process the data and do your programming there. Or whether you're just monitoring or you're doing some automation for controls. Okay. So let's proceed. Let's have further information by comparing Modbus to other protocols. Let us take a look at different sectors. We have residential, commercial, and industrial sectors. Okay. What makes Modbus popular is not with its speed, but with its diverse application and presence on these sectors. It's not the perfect. Modbus is not perfect. It's actually kind of slow compared to other protocol, but because of it's like Modbus is parang siya yung nauna. Okay, siya yung nauna. They're one of the first protocols in the market that was set to be an open protocol. So it became popular with other manufacturers to use a common protocol, which is Modbus. Okay, so in residentials, okay, just to give you a background of the application on these different sectors. Okay, sorry, let me just discuss some of these protocols. So for BACnet is a building automation control protocol, also used for BMS application or building management systems. Implemented in, last time I encountered this is on Johnson Controls. They are using BACnet to communicate their DDC controllers. For Schneider Electric, they are using the LonWorks protocol, and also DDC controllers for HVAC controllers that they have. MBus, on the other hand, is for energy metering. Energy metering such as electricity consumption, water consumption, and BTU metering. They are using the MBus protocol or metering bus. I think it's the short for metering bus. Applications under residential of these protocols, also including Modbus, are HVAC or heating, ventilation, and cooling, lighting controls or lighting monitoring, and energy metering. Devices that you can control or monitor includes variable frequency drives to vary the speed of your motor or pumps, lighting panels to control your lighting, okay? The motors for temperature and humidity sensors, pressure sensors, and DDC controllers. you will notice that under commercial, residential and commercial pretty much share protocols. Okay, this is not well, a disclaimer: this is not the only protocols on the market for these specific sectors. There's a lot. These are just some of the things that I'm quite familiar and I believe is quite known in these sectors. So similarly, BACnet, Loanworks, MBus, and Modbus, but the application is commercial applications such as HVAC for high-rise building, okay, high-rise building, supermarkets, okay, convenience stores, like what they call this, lighting, refrigerations, energy metering. For enclosed spaces and parking lot application, we also have the CO2 monitoring. For W stands for water and wastewater systems, okay, and the rest. Devices that you can control under commercial are compressors, fans, PLC, DDC controllers, valve drives, and thermostats, etc. Under industrial, with the different vertical markets in industrial sectors such as oil and gas, manufacturing, transportation, telecommunication, it is expected to have lots of protocols. That's why you can see here, compared to those other sectors, residential, commercial, you have lots of competing protocols here. This is because in the industrial application, there is a need for certain requirements, certain precision, speed, and credibility of those data and specific control of these devices. Standards in industrial is much stricter compared to the residential and commercial. That's why communication protocols cater to these specific needs. So what are those specific needs? It can either be application-based, it can be environmental factor. So for application-based, for example, let's have an example. Manufacturing line, let's say an SMT line. If you saw already some SMT machines, usually those are, there are some movable heads or what we call as end effector, and those are connected to servo motors. These are fast, high precision motion control applications, and it requires very fast data processing and transmission. Modbus cannot handle that. In fact, the speed of a typical Modbus is around, it's not real time, in short. In motion controls, one of the emerging popular protocols is EtherCAT. If I remember correctly, EtherCAT is boasting a 100 microsecond response time. So it's that's why it's implemented in these motion control applications. So again, application is one of the factor. Second factor is environmental factors. You will see here on the right side is DNP3 and IEC 60870. These are industrial communication protocols intended for power and energy usage, particularly substation applications. Because of the nature of the power industry, where there's a lot of noise-generated electromagnetic interference from these transformers, from these high voltage lines, there is a need for a specific sets of or capability of protocol to be used. So this is where DNP3 and IEC comes in. But nevertheless, Modbus is still there. Applications, SCADA, telemetry, water and wastewater, oil and gas. P&E stands for power and energy. Again, I mentioned manufacturing and motion controls. F&B is food and beverage. Okay, equipments or devices that you can control. We have the VFD, servo and stepper drives, PLC, PAC, and these controllers, I/O modules, flow meters, temperature and humidity sensors, pressure sensors, and etc. So this is an overview of communication protocols, its application, and what are the devices that you can monitor and control. Okay. So the next topic is the data structure. Let us have a look of how Modbus RTU transacts master and slave by defining first what is master and what is slave. Okay. So master. Master is a device that initiates the information requests. Okay. That's all it does. Okay. For this example, we have here a master device. And on my example, it's an Allen Bradley PLC. Okay. The slaves, on the other hand, is a device that supplies the information. Specifically, a device that supplies the information, meaning the master will send the request on the slave. Okay. And the slave will give it to the master. It's not the other way around. There's no other instances that the slave can just imagine the slave asking the master to give him money, right? It's in the word itself. So the master initiates the information request, and the slaves provide it. In this sample, in order for us to have a good representation between the master and slave transaction, I prepared this simple closed loop control system in a Modbus RTU setting. Modbus RTU, again, Modbus RTU is serial based. Okay, serial based. Modbus TCP is Ethernet based. So for now, we're just gonna focus on Modbus RTU. Okay, to also show that Modbus protocol can be used across third-party devices. It doesn't matter if it is from Allen Bradley and Engr's House or other devices. As long as you're using Modbus protocol, these devices can talk to each other. Again, open protocol. You don't need any gateway. Okay, you don't need any gateway to transform the data coming from this ultrasonic flow meter just for you to send it to the PLC. So it's not like that. That's one of the advantage of a Modbus having this open protocol feature. So for this example, we have the ultrasonic flow meter address number 1. Okay, this is a drop down, or sorry, a multi-drop connection. Okay, multi-drop meaning you have here the main line is your bus. Okay, and multi-drop meaning for the next one, you have another drop, which is for our Advantech relay module controlling the motor and the tower light status, address number 2. So multi-drop. Okay, if you look at it, it's like a in parallel connection. If you're going to expand this wiring, but it should be in daisy chain or multi-drop connection. Later, I will explain the do's and don'ts in network topology of Modbus. Okay, so I'll look forward to that. Okay, so multi-drop. So this one is Advantech. So as you can see, we already have 3 products communicating using Modbus. The next one is a Schneider Electric energy meter, address at number 3. And as mentioned from its definition, you can address these devices from 1 to 247 devices. Later, I will also give you the limitation on how many devices you can connect on a single branch. Okay, but for now, let's just focus on the master and slave transaction. With this, I prepared a simple logic, if you can call it. Okay, so that we can see the flow of data. Okay, so for example, as you can see here, the master would like to know the flow rate. Right now, the reading is 0, but on the ultrasonic flow meter, we are already getting 5.25 cubic meters per hour. So what the master will do is, again, it will initiate the read request. Why read? Because the master would like to read the 5.25 from the ultrasonic flow meter. So this bits of data represents the address and the request. So later we'll try to elaborate that bits of data. Okay. But before that, FAQ number 1. So how fast is Modbus protocol? In serial mode, the rate at which these bits of data are transmitted is determined by the baud rate setting. Okay, so it usually by default it's 9,600. There's also 19,200, and then up to 38,400 bits per second. So it's but compared to TCP/IP mode, the speed is determined by which Ethernet speed connection is being used, whether your network is connected in a 10 Mbps, 100 Mbps, or even 1 Gbps. So, okay, so from this one, you can already figure out, hey, TCP/IP mode is much better. Okay, so that's one of the advantage. It's much faster compared to the serial mode. Okay, going back. So the master will initiate the read request and sends it to the flow meter. Okay. The flow meter will accept the request and send a response, will send a valid response containing the value of 5.25. And there we go. We're going to have a flow rate of 5.25 read from the flow meter. Okay, the logic here is, on the next one, the logic here is the motor pump start command will turn on if the flow rate is greater than or equal to 5. Okay, so it's now on. So the master will send this time, this is a write request. Okay, a write request. So this is a write request, and this will send it to the Advantech at address number 2 to control the motor. Same thing, the Advantech IO module accepts the request, turns on its output. As you can see, it's now on. Right now it's still 0, but the actual motor is actually running right now. So it's right now it's 15 amps. So again, okay, we're gonna initiate a read request. Okay, slave device accepts that and sends the response. Okay, one more. We have the motor pump status, or our tower light. You know, some of you may call it as the andon lights. So it still says stop, even though our pump and the motor current indicates that it's already running. So on the logic here, if the current is more than 1 ampere, then initiate a command to turn on the green or running status. So again, write request. Okay, that to the Advantech IO module again. Okay, and then sends a valid response. Okay, question. So what happens if it is an invalid response? It only happens if the request sent by the master is wrong. Okay, meaning, for example, it's asking for a specific data that is not available on the slave devices. So that will be a wrong response. Okay, but usually this kind of issues, you will only encounter it on the initial stage of the automation project during the testing and commissioning. Okay, of course, you're not going to proceed with the project knowing that you're not getting the actual data, right? So that's why there is testing and commissioning stage in every automation project. Okay, so that's my example for the motor pump status command. So hopefully you can have at least an overview of the operation, or how master and slave works, or the transaction between them. Okay, 2 more slides. I'm gonna check some of the questions. I saw that there are some questions being raised on the Q&A section. So I will try to stop midway, okay, to answer those things. Next one, we have, okay, I told you a while ago that we will try to dig deep a little bit. Okay, this is we will try to dig deep on the read requests, or the data structure itself. Okay, on the data structure, which is particularly right now we are doing the requests. Okay, let me tell you now that this is not important, but I would like to share it with you, so at least you can have an overview of the raw data structure. Okay, again, raw data structure, meaning if you're already familiar with Modbus, you're not going to encounter this one anymore. Okay, so later on that. So quick one. This data structure request, as you can see here, we have a read request in terms of binary, zeros and ones, 110, 01. These are binary. So if we convert it into a hex format, so that it's easier to understand hex compared to ones and zeros, right? So what you will see if you convert it into a hexadecimal format, the first byte on the request data will indicate you the device address. Okay, 01 is in, everything is in hex. Okay, so the good thing is our ultrasonic flow meter address is 1, and the equivalent hexadecimal value of 1 is also 1. So that's why 01 is equal to 1 in decimal value. Okay, so first byte is device address. So it's intended, meaning this request is only for address number 1 to identify the destination of this request. First thing on the data structure. The next byte indicates the function code. It specifies whether to read or write single or multiple registers of a specific memory table of the slave device. Oh, medyo wordy, right? It's like wordy. Again, don't focus on this much. You will forget this. Okay, you will forget this once you have encountered the shortcut method. Okay, so function code, there is a specific table called the function code table defined by the Modbus organization to specify the actions of a Modbus protocol. So we have here 1, 2, 3, 4, 5, 6, 7 function codes in hexadecimal format, each with its own single write or read functionality, and whether if it is single or multiple actions. Okay, so the first one on the list is 05, which is writing single discrete output coil. Okay, output coil, you can for now we're kind of early, but output coil is an on-off signal. Okay, you can just imagine an on-off signal. Okay, so that is the issue. 05, you will issue 05 function code if you want to write a output coil or a digital output, in short. 0F is to write multiple. Okay, so if let's say multiple output coil address, you would like to make them all on, then you're going to use the function code 0F. For the read, 02, 04, and 03, this is for 02, it only has the capability of read. Okay, in input contacts, same thing with output coils. This is also discrete signals, but with the term for this one, the correct term for this one is a digital input. That's why you cannot write on that discrete input contacts. Next one is 04 and 03, analog input registers, analog output holding registers, and so on for the 06 and 10. But I'd like to focus on 04 and 03 because as you can see here, we have selected 03. But according to this one, it's analog output holding register, right? It's analog output holding register. So why did we select this one instead of 04? So later on that, I will have more topics to explain this section right here. Okay, but for now, either way, you can still use you can use 04 or 03. This is determined by the manufacturer of the instrument whether to use 03 or 04. So again, let's move on. 03. We used 03 on this one. The next set, the next 2 bytes is for the data address. It specifies the start address on which the data will be read. It says here that at data address 0063, this is where you're gonna get the 5, or where you're gonna read the 5. This is where the 5.25 is stored. So that's why we are going to access the address 0063. So it's already in hex. So we're gonna use it directly. Okay. The next set of data is the number of registers, specifies how many registers are needed to be read. So on our example, it's 1 because we only have one data address to access, which is 0063. If, okay, so sorry, I have to zoom a little bit. So if the number of register is equal to 3, then the master device is requesting access to the data address of 0063, 64, and 65. 3 data address or 3 registers. Okay, so hopefully that clears that up. If you have any questions, just fill up those Q&A sections. I have one more slides and then I'm gonna check those things, okay? And then the last one is a auto-generated data called CRC, or short for cyclic redundancy check. It is an error detecting code commonly used in digital networks and storage devices to detect accidental changes to raw data. This is only available for Modbus RTU, serial communications, okay? Again, this is a automatically generated value. Actually, it is a representation of the data from this 01, the red one, up until this 01, which is the green one. So any changes with this data, so if, for example, if I send this data to the slave device, the slave device will check, is it still 74 and 14? And that means your system is the data that was received is credible and correct. Okay. Usually you don't see this thing. You don't have to you don't have to concern yourself on these things. Okay. So that's how we do that's the breakdown of the data structure of a request. Now, on the other hand, for the response, it's much simpler. Again, the device address number 1, 02, 03 for the function code, which is again, read analog output holding registers. 02, this is a bit different from the request data structure because this 02 indicates the number of bytes. It specifies the length of the data in bytes. So again, since we are only accessing one address or one register 0063, it says here an analog data address or register has 2 bytes. That's why we have 2 right here. Okay. And the next 2 bytes is for the data itself. Remember, we are reading 5.25 cubic meters per hour. Okay, cubic meters per hour. Okay, 020D is in hexadecimal format, and if you convert it to decimal, you will be able to get 525. Again, 525 is not 5.25. So again, this is the raw value. Okay, so the engineering value, all you have to do is divide it by 100, and you will be able to get the 5.25. Later, I have some examples on what are those methods in converting raw values into engineering values. So don't worry that much as per now. And then also the same thing, CRC for this sample. Okay, before we go through that, let me just check the next slide. Okay. Okay, yeah, the next one. So the next one is the shortcut, okay? You don't have to interpret those data. But before we go through that, let me see if I can answer some of your questions. Okay, from Mr. Frobel Caluna, his question is, for analog current signal, why do we use 4 to 20 milliamps signal instead of 0 to 20 milliamp signal? It kind of varies. It is actually specification given by the instrument manufacturer whether to give 4 to 20 milliamp or 0 to 20 milliamp signal. It depends on the instrument manufacturer. So if you check the data sheet or the manual, it will definitely tell you what kind of electrical signal you're supposed to get. Okay. Second question. I have an Advantech data acquisition module taking data from different PT sensors and Siemens. Okay, why do I need in order to interface or to be able for those two devices to talk each other. Is it possible to do it in TCP/IP? This is from Christian and Nave. Okay. Siemens S7 1500 PLC. I worked with this PLC before, but if you can check if it has a separate Ethernet port in which you can set it to accept Modbus TCP. Okay, so method number one: check the PLC if it has a spare Modbus Ethernet port and set it to accept Modbus TCP. Second question is, what type of Advantech data acquisition module you are using? Is it Modbus TCP for Modbus TCP, meaning using Ethernet, or Modbus RTU using serial? So because it's the interface, right? So if you have Modbus TCP, then that means your S7 with an Ethernet port can communicate directly with each other. Okay. For RTU, for Advantech data acquisition module that has a serial connection like RS485 or RS232, check the Siemens S7 1500 if it has a port to accept serial connections. Okay, I believe on the TIA software, if I believe that is the programming software for Siemens, you can enable a specific communication port and enable the Modbus connectivity. What are the keys? What are the keys that we consider as end users to address this growing challenge? Makes obsolescence is always a problem in the automation. Obsolescence. This is a good question. If Macmillan Gomez, let me get back to you on that one. Okay, I'll get back to you on that one. For Jason, some of my guys use FOC, fiber optic connectivity. If am I right? As link for Modbus TCP. Considering that it is master-slave system and communication takes place one device at a time, don't you think that there is over design of the media use? What is the amount of data given by a field device to the master? Okay, you are fiber optic, right? FOC as link for Modbus TCP. Modbus TCP can already handle a huge amount of data in fast response time, already considering fiber optic connectivity. Okay, it's over design. I believe it's not over design if the intended application requires fiber optic connectivity. Okay, let me give you why probably they used FOC. Modbus TCP again is Ethernet based, and as we may all know, if we're going with wired solution, meaning you are going to use a Ethernet cable, Cat 5 or Cat 6, it has a limited length, right? A typical end-to-end connection of Ethernet cable is around 100 meters, and it is even susceptible to noises if it comes through with any high voltage lines. Unlike fiber optic, in which it's not susceptible to electrical noise. So that's one, and the distance covered by fiber optic is much greater. So that's one of the main reasons why they might have resulted in the Modbus TCP. And then let me try to answer one more thing from Mr. Rolando. What is the impact of just plugging out a particular PLC in Modbus system just to reset it, especially if it is showing fault indications? Any proper way to fix such faults? Modbus is widely used in international commercial vessels. What is the impact of just plugging out particular PLCs? Is this like I believe you're referring to retrofit, right? If I'm correct. But later, if I didn't answer your questions correctly, I will share my email address for you to for us to have a discussion regarding my answers to. Okay, but I believe. Okay, I believe this pertains to retrofit jobs. For example, there is an old system using this PLC and also using Modbus. Is using Modbus, and then you're going to upgrade the hardware. It's a good thing if you're also using the same hardware, okay? You have all the data, meaning all the data, you're not missing anything. The connectivity, the addressing, the number of devices, this configuration, everything is the same from the old device. I don't think you're gonna have issues on that. Issues happen if there's incompatibility with the hardware itself, okay, or probably some settings are not met during the retrofit of these systems. I have a tool later, Mr. Rolando, that maybe you can use in order to troubleshoot this issue, okay? We use this software in troubleshooting Modbus TCP if the issue is caused by the Modbus connectivity issue and not the hardware itself, okay? Because those are two parts. We have the hardware also, okay, actually we have three. We have the hardware, can be the PLC, hardware. Number two, the logic, the program. Are you sure that the same program are you sure that you are using the same program and there's no bugs, or during the migration of the codes, there's no issue with the new firmware, something like that. And the third one would be, usually the culprit is of course the communication, and this is where we can do the troubleshooting with the Modbus, okay? It can either be those three, but I will give you some tools on how to do that. Okay, it's a good question. Let's proceed. Oh, what's the time? 8:37, 7:30. Oh, we only have a limited time. Let's proceed. It's a good thing we're already halfway. So, okay, let's go back. Modbus registers. If you remember, before we went with the Q&A, we are discussing the data structure. You already saw that it's quite complicated. Does that mean we have to always interpret those series of bits, zeros and ones, even the hexadecimal values, in order to get the data that we want, the engineering value? The answer is no. Okay, as mentioned, those are raw values. Okay, and this is where Modbus register takes control. Okay, this is actually the Modbus register is a standard that Modbus organization has set in order to simplify the addressing of Modbus protocol. But before we go through that, let's discuss data type. Okay, I think this is a very important topic. Most of you have already tackled this, okay, are quite familiar, especially from the automation side, but let me give you a quick run through. Data type, as you can see, it's a lot. Again, not needed, but important to know, okay? So I have here several data types, starting with the Boolean. So Boolean, or sometimes referred to as BOOL or bool, okay, by the IEC 61131 International Standard Code for programmable logic controllers, defining the programming languages and the data types. Data types is also defined under that IEC 61131. Okay, we're going so far. Boolean is 0 and 1, so on and off. Okay, in decimal form 1, in hexadecimal 001. Oh, sorry. 16-bit and unsigned integer. Integer, by definition, is a whole number without any fractional components. So 16-bit unsigned integer is unsigned, meaning there's no negative value. It's a whole number without any fractional values that doesn't have any negative components. Okay, so example here, 1, 2, 3, 4, 5 in hexadecimal form 3039. On the other hand, if it is signed, then the value range differs. Now the range is from negative 32768 to 32767. Okay, one of my example here is a whole number with a negative value, which is negative 1, 2, 3, 4, 5. Now you can note, you might be able to notice that on the value range, the value range is quite limited, right? 0 to 65535, negative 32,000 to positive 32,000. So for bigger numbers, we can use double the bit rate, which is double the memory, which is 16 times 2 is 32 bit. Okay, So for unsigned, if you are now using 32-bit unsigned integer, the range now is from 0 to 4 million. For 32-bit signed, it's negative 2 million to positive 2 million. We are talking about integer values, okay? There is another type of 32-bit code, the floating point, in which it's not considered as an integer, but it's a real value. A real value, it has fractional components. It can either be negative, positive, or 0. The good thing with floating point number is that it has a far wider value range. As you can see, it's 1.2 times 10 to the negative 38 to 3.4 times 10 to the 38. 3.4 times 10 to the 38. So it's a very useful data type in terms of getting that precision value. Okay, term is precision. Do you require precision on the data? Then use floating point. Okay, and some extra data. We have 1 byte character. 1 byte character, usually known as char. Okay, value range is for 0 to 255. For each decimal value, 0 to 255, there is an equivalent ASCII value. So for example, if you have a character A, a character is always usually indicated as with a quote, okay, with a quote, and then the character itself is A. Its equivalent hexadecimal form in ASCII is 0041. So if we go to the string, a string is a collection of characters from 0 to 254 plus additional 2 bytes. I believe the 2 bytes is to indicate how many characters are, or what is the length of the string. For example, on my example here, it's ABCD, so that means it means you have 2 characters, the length of the string. That's why you have those 2 additional bytes. So 0 to 254 characters. So my example here is the ABCD. Hexadecimal form is 41. And remember, for A is 41. So B is 42, C is 43, and 44 for 44 for letter D. Okay, let's try to hasten the time. Okay, examples. For the Boolean, it's pretty straightforward. It's only an on and off. Examples are motor controls, motor contactor with overload relay. Okay, like motor. From our example, motor on, motor off. The status. If you have a overload relay, you can detect if it is faulty or not. For applications, for door open close status using magnetic door read switch. Okay. Magnetic door read switch that provides open and close status. Water level indicator to detect the water level. Usually in tanks, there are float switches in industrial applications. Okay, in industrial tanks, there are 4 float switches installed on the tank, indicated by the lowest one is the low float switch. The next one is the low, and then the high, and then the high float switch. Okay, 4 sections to indicate the levels of the float switch. So, but this is still digital. Okay, meaning if the float switch high is triggered, then that means the water level on the tank is on the highest level. Okay, or probably critical level. Another Boolean type is a water flow indicator, which is a paddle flow switch. To indicate the flow of fluid in a pipe. Okay, proximity detection using a photoelectric sensor. Okay, presence, or sometimes used for counter. Airflow detection. It's been a while since I encountered this device. Airflow detection, and this one, a differential pressure switch, is used for HVAC applications. Sometimes used for detecting the operation of the fans, whether if it is running or not. Because if your fan is running, then that means you should be able to get a differential pressure, okay, on this device, and it will trigger an on signal. Okay. Another application is for in HVAC. If you in HVAC, if you saw an HVAC vents, there are also some filters. It can also detect if the filter is dirty or clogged. Why? Because if we have a blocked air duct system on the intake, it will you will have a greater pressure compared to the outtake, or after the filter you will have lesser pressure, and depending on the settings, then you will trigger the differential pressure switch. Okay, some examples only. When it comes to the analog signals, so there's a lot. Okay, let's try to zoom in a little bit. Examples right here is the power monitoring, smart energy meters. As you can see here, for the voltage, current, power factor, we can use either integer. INT is short for, let's zoom out, sorry. Integer is short for signed integer, because we can have either positive or negative voltage, positive or negative current, and power factor as well, positive or negative power factor. Okay. Also, float. We can also use float. For example, for greater precision on the voltage, like you would like to monitor 3 decimal places after the 230, for example, 230 volts for 0.12345. Then you can use floating. Humidity monitoring. Humidity monitoring is in terms of percentage, so that means there isn't any negative values. That's why I used UINT, or unsigned integer. For pressure monitoring, we have unsigned integer or float. Okay, for pressure monitoring. Unsigned integer, it depends on the manufacturer. Sometimes they set it as integer, or as a signed integer or unsigned integer. But if you can imagine, if you're not supposed to get a negative pressure, not unless you're getting backward pressures or something. It's supposed to measure that. But for now, we can assume it's unsigned integer. Temperature monitoring, integer, of course, because negative positive temperature is possible. Floating as well, for greater precision. For proximity detection, oh, sorry, this is not proximity detection. This is supposed to be flow rate detection. So for the volume, the accumulated volume, meaning we can set integer for the flow rate, right? Integer or float for the flow rate, but the accumulated volume, which is in cubic meters or liters, it's a positive value, positive accumulating value. So it's not supposed to be a negative value. And last on my example is luminance. Okay, unsigned integer and unsigned double integer, depending on the manufacturer's requirement. So one of my example here is our tower light sensor. So this is a non-invasive tower light sensor that you can just zip tie on the tower light, and it can detect whether your lamp is off, on, slow blinking, or fast blinking. Okay, and you can also detect the luminance level, okay, the intensity, so that you can set the set point or the bandwidth for that one. Okay. Let me correct this one. Okay, let's go with the FAQ number 2. Let's proceed. Sorry. Okay, FAQ number 2. Sir, integers or whole numbers, no fractional component. Then how do we get analog values with decimal places? On our example, we have actually 2 methods, okay? But there is a disclaimer. I'll give you the disclaimer later. I would just like to give you these 2 methods, okay? First method is scaling factor and offset. If the scaling factor and offset is given on the manual, for example, on our example a while ago, we are reading 5.25 cubic meters per hour. If the data is indicated as unsigned integer, okay, then we're going to read 525. Remember that? 525. So it's not 5.25. So that means we need to check the manual. What is the scaling factor? Then you should be able to get scaling factor of 0.01, and probably you're not going to use offset, okay? So that's why on this one, it's just 0. So for the formula, engineering value is raw value times scaling factor plus offset. So 525 times 0.01 plus 0 is now equal to the actual reading, which is 5.25. Raw value to engineering value. So this is the one that I'm talking about. Converting the raw into engineering values. Okay, this is one method. Method number two is if the engineering high and engineering low values is given on the manufacturer's datasheet or user manual. So for this is mostly common in temperature sensors. So for example, PT1000 temperature, if we are reading a negative 35.3 degrees Celsius and the data type was indicated as integer, remember we have this, for integer, our value range is negative 32768 and 32767 for the raw high, okay? And we are reading negative 31228. Just look at this data. The actual reading is negative 35.3, but we are reading negative 31228. Okay. Okay. So how do we convert that to engineering value using the engineering high and engineering low method? Okay. By the way, PT1000 is given, and the range given is negative 40 to 160 degrees Celsius. I will not go through with the formula, but this is just a simple interpolation calculation. Okay. Between 2 points, you can determine a specific value in the middle of these 2 points. Okay, that is the interpolation method. And by implementing that data, you will be able to get negative 35.3 degrees Celsius as well. Now, you don't have to do this computations, manually program it on your PLC just to get this data. Okay, most I/O modules right now have these built-in features to enable these calculations for you. Okay, so you just have to you'll just have to plug in the engineering low and engineering high respectively, and it will do the calculation for you right away. Okay. So this, for the disclaimer, so this method is applicable for 16-bit registers or 16-bit registers, low precision. Remember, the range is around negative 32,000 to 32,000. Okay, and these are integers, which is normally doesn't have any fractional data. So manufacturers will just use the floating point value instead of those 16-bit data. It's much easier to work with. You'll just have to use this 32-bit data, and you will get the real value without having those computations. You will actually get the actual value itself. Okay, no more calculations, no more determining the engineering low, engineering high, remembering what is the range of integer and unsigned integer. So no more for that. Okay, and then let's go with the last one. Examples for the character and string. We have entries from barcode entries, such as for barcode entry, we have QR barcode. For HMIs or human machine interface, we can put their alarm codes, or for example, the operator can input some small some text or messages, short messages, okay, to send it via the automation protocol, sometimes Modbus. Another one for the use of ASCII codes is for if you are monitoring the firmware version of your device. For example, this particular temperature controller has a firmware version of combination of alphanumeric characters. Then you can use this character or string data type. Okay, FAQ number 3, just a quick one. Okay, this is also applicable not only for character and string, but also for number or analog data. So the way data are stored, in the manner of which data is stored, first in the memory is defined by the setting, big endian and little endian. For example, ABCD is stored as 41, 42, 43, and 44. 41 is A, and then D is 44. But if it is indicated that it is little endian, then that means you will read first the last or the lowest value, which is D. D to 43, it will be D, C, B, A. So that's just an FAQ if you are going to work with characters and string. Let's move on. So those are the data types. Now let's go to the shortcut, which is the actual topic of our this one. So Modbus registers, also known as Modbus address, refers to the 4 data tables at which the data are stored on the slave device. Two tables for storing on-off discrete values and 2 for storing analog values. Each table having to, in which you can store up to 9,999 values. Okay, I mentioned you don't have to remember or interpret those bits of zeros and ones. You can just refer to this table. This table represents on the description each memory address on the slave devices. So there are 2 for the digital signals, input and coil. For the output, we have input register and holding register. Input status and coil status, as I mentioned, these are digital input and digital output respectively. They only deal with digital inputs, with digital signals. The only difference is that, other than the register number, is input status only has read capability, while coil status have both read and write capability. Okay, in order to distinguish input status from coil, okay, you can check the register number. If it is from 0 to 9,999 and it is a digital signal, then that's input status. If it is 10,000 to 19,999, coil status. And same thing for input and holding registers. But this time it's using, it is for analog inputs. One register is 16-bit, or we commonly refer to it as word. One word is 16-bit, one register is 1 word. Okay, so input register is for reading AI. Holding register is for read and write AO. Okay. Sorry, medyo binibilisan ko na. We're kind of limited na eh. Okay. Examples for input status: motor status run stop, door open close, light status on off, level indicator high and low. Remember, input status is only has read functionality. So that means, for example, if I am the master and I'm gonna ask, hey, what is the motor status? And the slave device will say, I'm running. Okay. As a master, once I receive that, oh, you're running, I don't believe you. You're off. You cannot do that with input status. Why? Because I cannot tell an input status or write the input status to tell me that it's off, because it only has read capability. So even if I keep on telling, no, you're off, but in actual, if it is running, then what you're gonna get is a running output. Okay, read and write. Okay, we have limitations. So as you can see here, master device will not be able to send write request to slave device. Only read request is allowed. But for coil status, such as motor command, right? Writing command is writing. Enable command, lighting command, level indicator. Oh, sorry, this is wrong. Okay, the level indicator is wrong. Just disregard that one, okay? But for coil status, it's a digital register in which it can either read or write. Input registers, temperature, pressure, flow rate, and speed feedback with read functionality as well. So similarly, if the temperature sensor tells you that, hey, I am 0 degrees Celsius, and I tell, no, it's warmer, it's 10 degrees. I will write 10 degrees to you. No, it will not accept that. It will always send 0 degrees if it is reading 0 degrees. It only has read and cannot accept write requests. Holding register, okay, is speed command. Example, your slave device is a VFD and you would like to turn on, or you would like to run the motor or the fan at 50% capacity, then that's speed command and analog output. Writing. Set points, right? Bandwidths, time and date settings. These are mostly settings because you can write on the slave device, right? So same thing, read and write is applicable. FAQ number 4. Okay, Miss Jacqueline, let me know if how many more minutes I have so that I can try to cover as much as possible some of the remaining slides. Okay.
Sir, no problem po.
Okay, so I can still continue, right? I think I just have a couple of 5 slides.
No problem, sir.
Okay, FAQ number 4. FAQ number 4. Why is it that I usually only encounter holding register compared to the rest of other Modbus registers? On my example right here, this is the WISE S100 Intelligent Stack Light Monitoring Sensor, and this is the Modbus table. Modbus table is the table that contains the Modbus address and the data that you will be able to read once you access that address. It also involves some attributes, whether if you can read or write that data. You can find Modbus tables in user manuals. Okay, user manuals. Okay, so as you can see here, address 4X 40,001 to 40,002. Everything is holding register. Again, 40,000. Okay, why is it like that? Because holding register is the most used type of Modbus register, since it has both analog. Remember, holding register, it has read and write functionalities, and one register is a 16-bit resolution. So that's why we can also include read and write functionality for discrete signals by accessing those 16 bits. In this example, I forgot where did I took this screenshot, but this is an example of a Modbus address at 40,201. And it says here, the description is to toggle the relay on and off. And it's 0 to 7. So my interpretation for this device is that if you access, you can control relays 0 to 7, or that means 8 relays by accessing the individual bits of 40,201. Okay, so you command, for the example, command to turn on relay channels 0, 2, 4, and 6. Okay, on the programming level or on the I/O module itself, it varies from brand to brand, but the way it is, I believe in Siemens, you can access it like this, but correct me if I'm wrong, okay? So 40,201, to access the first bit, it should be .x0. So that, then you set it to 1 to turn it on. And this is it. Okay, and then 2, channel 2. So that's why 40,200.x2 is equal to 1. So as you can see here, 0246 is an alternating address to turn on. So that's why the equivalent output, if you expand the 40,201 16-bit into binary format, you will see here the alternating values as well. 10, 10, 10, 10. Reading is from right to left. Okay, it's not left to right, always right to left. So that's why this bit is for this lamp. Okay, and now it's alternating. Okay, that's why you will always, most of the time you will always encounter holding register. Go back. Okay, let's go back here on the holding register. 40,000. Always try to remember this. The easiest way to know the different types. Actually, I just remember the offsets. Okay, for input status, if it is 0 to 9,999, input status yan. If coil status, 10,000 yan. If input register, 30,000. And yung pinaka-common, huwag niyo nakalimutan, syempre. Holding register is 40,000. Okay? So 40,000. Lagi niyo alam, 40,000 yan, holding register yan. Okay? So that's a tip for me. Okay? And then, now, there will be some modification when it comes to the type. Kasi sabi natin kanina, DI, DO, AI, and AO, but since holding register can handle everything, then yes, holding register can handle all these types. Okay? Okay, now application na tayo. Ano, wag na tayo sa theoretical. Let's not go into the theoretical. What I have here is some sample Modbus tables from different manufacturers. So what I have here is a pressure transducer from a manufacturer APG, a PT500. That's the part number. Okay, according to their Modbus table, again, on the Modbus table, so this is the information that we can get. Okay, it uses holding registers. Why? 40,000. Okay, highlighting 400 to 402. If not given by the manual, we can assume that 400 to 402 can be set as type unsigned integer. Why? Because according to the value range, there is no negative component. Okay, so it's safe. It's safe. Next finding. However, 40,407, as you can see on the value range, is negative 15,000 to 30,000. So that's why you're going to set the data type as integer to accommodate for the negative values. Okay? Okay, let's move on to sample Modbus table number 2. DuraPulse, this is a DuraPulse series AC drive, VFD. This is a VFD. Okay, what are the data that we can extract from this based from the topics that we have already covered? Hexadecimal addressing is the equivalent Modbus decimal of data address. Where is that? Oh, yeah, it switched. So for the first bullet, as you can see here, 2,100 hexadecimal. If you convert that to decimal, it's 8448. Okay. Remember holding register. Holding register is 40,000. So the offset for that, so you have to add the offset, which is 40,001. That's why here 48,449. You're gonna get 48,449. So that means it's the same. 2,100 Modbus address is equal to 48,449. Okay, don't be confused. But if ever you're confused, email me, send me this table, and then I will help you interpret the Modbus table, okay? And there's a mistake on the slide, but manual indicates read only. So that means we can only read this following datas. The firmware version percent load, we cannot write anything to this. Okay, simple. Sample Modbus table number 3 was okay. This is much complicated. This is courtesy by Emerson Rosemount 8750 W flow meter on this video on this photo. So what are the data suite that we can get from this Modbus table? You will already notice that I have two tables right here. One is Modbus registers. It's for the 40,000 series holding register. Okay, this is for the holding register, and as you can see here on table C-2, it is for Modbus coils. So remember, Modbus coils is from 1 to 9,999, and it's digital, read and write. So that's why. Okay, you can see here, read and write, and it's coils. Okay, what are the data that we can get? If we access 40,197.x2, okay, the bit or bit number 2, it will give it will give us the status of the processor failure on and off status. Okay, you're only gonna get 0 and 1 when you access bit. Okay. Next, writing a value of 1 to coil address 97. Okay, so this is already 97. Okay, you're not gonna add any offset because again, coil status starts from 1 to 9,999. So coil address 97 as it is will enable the flow limit alert 1. Okay, so this is a read and write capability. So that's why you can write values onto it. Okay, to answer as promised, forgot his name but if you're listening, this is the actual software tool that I'm using in troubleshooting and further understanding Modbus protocol. So FAQ number 5, what Modbus software tools can you recommend? Okay, I have these two softwares right here. ModScan is a Modbus software tool developed by Wintech that operates as a Modbus master. Okay, the yellow one is the Modbus master. Okay, it acts as a Modbus master. It can support both Modbus TCP and RTU. On the other hand, ModSim, okay, from the simulator sim itself, it's simulating the data. So it acts as the Modbus slave. Both softwares are developed by Wintech. Okay, you can actually download the software for free, a trial version at their website at www.win-tech.com for a trial version. Okay, so how do I use this software? Okay, you are having issues with the retrofit of a replaced PLC with Modbus connectivity, right? It depends on the requirement. Maybe you're hoping that I can get more information. So for example, let's say you would like to troubleshoot. Maybe the problem is the slave device. Then I'm going to install the ModScan on my laptop. Okay, connect the laptop to the slave device. Whether if your device is a Modbus TCP, then the connection means is what? Ethernet. But if the slave device only offers Modbus RTU, then it can either be 2-wire for RS485 and or point-to-point, which is usually RS232. Okay. Next 2 slides are network topology. Last part. Okay, so that's how I troubleshoot. Okay, so with ModScan acting as the Modbus master, I can send the request to read and write from the slave device. If I'm getting data, or I was able to establish connectivity, then I can say there's no issue with the slave device. Okay, this is my go-to software, ModScan, very useful. Next, ModSim. This one, I use this if I don't have any slave device and I have a PLC. And what I want to do is send simulated simulated data to the PLC just to check if the PLC is receiving it. Then I'm going to use the ModSim. Again, ModSim acts as a slave. Okay. So that's how I use these 2 softwares. For those of you who don't have both a PLC or a instrument device, you can connect these 2 softwares together. Okay, within the same PC or even remote PC. Okay, you can connect ModScan master and ModSim slave with each other, and they can actually read each other out. Actually on the background, I'm actually doing that. Okay, so as you can see here, this is again, yellow is the master, gray is the slave. So for example, the slave has a reading of 1, 2, 3, 4, 5, and it's reflected on the master. Okay, let me just demonstrate you real quick the read only capability. Okay, remember for coil, for digital signals for read only, which is input status, offset is 10,000. 10,000 input status, read only. Okay. As a slave, of course, I can change the data because this is the Modbus slave. I put here 0, the master gets 0. But the master cannot. As you can see here, I'm changing it, but I cannot change because I'm the master and this is only an input status register type. Only read capability. For coil, okay, if I go to coil, I can do read and write. So as you can see here, I can do it now. Okay, I put here 1, it reflects on the slave device 1. Okay, so this is a very useful tool for those of you who would like to explore more on the automation side of Modbus protocol. Okay, self-taught. You can teach yourself on the Modbus protocol, but just by using this software. Okay, and last 2 important slides, to be honest. Last 2 important slides are. Remember, I always mention Modbus RTU, Modbus TCP, but what are their topology or their wiring or their connectivity? Modbus RTU, remote terminal unit, or short for remote terminal unit, is a serial communication protocol where serial bits are sent through serial lines of either RS232 or RS485. I mentioned on the FAQ number 1, the speed is determined by the baud rate. Addressing is done by unique ID from 1 to 247. Comparing the 2 communication means of either RS232 and 485, you will already see the differences and the advantage and disadvantage between the 2. RS232 maximum RS-232 distance is 15 meters. Okay. And since the RS-232 is dependent on a 3-wire TX, RX, and relative to common or the ground, pretty much a full duplex communication, your connection between the master and slave will be quite limited. It will be point to point, one master, one slave. Okay, one master and then one slave. However, for Modbus RTU RS485, maximum length is 1,200 meters. Okay, from point to point. Okay, you can connect up to 32 devices. Okay, but for the wires, it only requires 2 wires, TX and RX. So this one is half duplex. So that's why the connection, you can do multi-drop or daisy chain connection on this network topology. Addressing is from 123 up to 247, but it has a limited number of devices per branch that you can connect. Maximum is 32 devices, but it can actually go even higher if there's no, for example, you only have, for example, each devices in the data being transmitted is not quite high. You can extend the devices you can connect on the Modbus RTU topology. Okay, FAQ number 6. What are the common practices in wiring Modbus RTU? Okay, baud rate. Okay, between master and the slave, everything must be consistent. When you are setting a serial port, remember, we are setting the baud rate, data bits, stop bits in parity. So it should be the same and consistent from the master down to its slaves. Everything should be the same. Otherwise, you're gonna have error on your connection. Also, unique addressing of slave ID. There should not, again, it should be unique, meaning no two slave ID should have identical addresses. Number 2, ensure proper device connection. As mentioned, maximum is 1,200 meters. Branching is 1 meter, but this, although my term is branching, it's still on the daisy chain connectivity, okay? Daisy chain connectivity. 1 meter, okay? You should not practice this, okay? At any point in Modbus RTU, okay? What's this? I forgot. This is not this. Yeah, I believe this is a star, but correct me if I'm wrong. But again, do not use this. This is a wrong network topology for Modbus RTU. Last, use twisted pair shielded cable to avoid signal reflections. Use twisted pair shielded cable. This is for such as Belden 3105A. It's a 2-core twisted pair shielded cable with an earthing shield. This is to prevent your Modbus RTU network from electromagnetic interference. If it is close to high voltage wires, motors that can induce voltages on your communications lines, then use this Belden 3105. So that's the use of shielded cables in Modbus RTU. But to avoid signal reflections, use a 120 ohm terminator resistor at the end of each main cable. So as you can see here, from the start, from the master itself, I have a 120 ohm resistor before I connect the slave 1. Before the slave 1, I have a 120 ohm. And at the end, okay, just make sure that this is the end, meaning there's no slave 3 at the end of after this line. So at the end, another 120 ohm resistor. Okay, will it work if I don't use 120 ohm resistor? Yes. In small, if your line is less than 50 meters, you don't need 120 ohm resistor, or for testing purposes, you don't need a 120 ohm resistor, especially if the distance is not that great and the transmission load is not that high. Okay. And lastly is the Modbus TCP. So Modbus TCP, so with all those serial bits that we have encountered, the data structure. So Modbus TCP encapsulates this serial codes or data structures into TCP IP packets. Okay, so instead of slave address of 1 to 247, each device has its own IP address communicating to port 502. 502 is a port that is specifically assigned for a Modbus TCP protocol. So try to remember this. Okay, port 502, you will always encounter this 502. This is a dedicated port for Modbus TCP protocol. Okay, as I mentioned, unique IP address. Okay, so instead of master slave terminology, the correct way of describing devices within a Modbus TCP is client and server relationship. Okay, because unlike Modbus RTU, you can there can only be one master, but in Modbus TCP you can have multiple master, or in this case, multiple clients. Okay, so as you can see here, we have address at 0.10, 0.11. Okay, and we have a PLC. A PLC can be one client, SCADA, another client, HMI, another client. Okay, and because we are using TCP/IP protocol, which is a prevalent technology, and we are still using this, we can implement those wireless technologies that is also related to Ethernet. To TCP/IP. One such thing is, for example, we have here a remote I/O module. A remote I/O module, so it can communicate with a Wi-Fi. This one is a Wi-Fi access point. So okay, so that means Modbus TCP is being sent through the Wi-Fi, network. Okay, Wi-Fi but Wi-Fi has limiteds. Similar to Ethernet cable, 100 meters is the maximum length. Of that you can put these 2 points together. In some cases, in some of our products, our wireless I/O modules cannot not only provides Wi-Fi. We also have, if you've already heard, LoRaWAN. LoRaWAN, we also have that. Our I/O modules that has a built-in LoRaWAN capability. So LoRaWAN, for those of you who don't know LoRaWAN, it's a wireless free license protocol. Low power. LoRa is low power but long range. Low power, you can low power. It's a low power, long range. You can power up this I/O module by using batteries. Okay, and it can last up to 200. It can last up to 2 years. Okay, so low power. Long range, the range for a LoRaWAN is 5 kilometers, and it's free. It's not LTE. It's not 4G. It's not 5G. It's LoRaWAN. Okay, but it's free, 5 kilometers, meaning it's wireless connectivity. It's wireless. Just imagine the possibility of connecting or detecting a temperature without any wire for 5 kilometers. Okay. If you can imagine that, right? Imagine the technology of LoRaWAN. So it's already we already have that product. If you're interested, LoRaWAN. It's already, the license we are using for LoRaWAN is 868 megahertz. We already have the NTC approval or NTC certification for that, and it's readily available in the Philippine market. Okay. Commonly for short range wireless, we go with Wi-Fi. But for long range, we propose LoRaWAN. Okay, so that's for Modbus TCP. Okay, Modbus TCP. Okay, for the application and case study, number 1. 3 more slides, I promise. Application and case study number 1. I have the OEE and alarm monitoring system. This is an ongoing project or more of a demonstration. Proof of concept in one of our semiconductor customers here in the Philippines, in which we are implementing an OEE systems, and we are monitoring the SMT machines tower light status. So the application is for machine status monitoring. Okay, if you may know, OEE is the product of availability, quality, and productivity. So for the availability, so we are using the WISE S100 to detect the operation of the machines, whether if it is running, if there's an alarm, if it is idle. Okay, this WISE S100 is communicating to the HMI using Modbus RTU, meaning serial, Modbus RS485. Okay, and the HMI itself, okay, in which you can enter the alarm code. If there is an alarm, the operator can put the alarm on the HMI, and that alarm, we convert that alarm code into Modbus data. Remember, we can send an equivalent Modbus ASCII character for each letters and numbers. So the alarm code, for example, ALM00B, we are sending that to this IIoT gateway, to our OEE server, and up to their Oracle database. Yeah, so that's actually how this project goes. We are pretty much using two technologies of Modbus. We have Ethernet for the blue one, Modbus TCP. Daisy chain for the RS485 for the WISE S100. Okay, two technologies on one project. In one of our substation SCADA application in Indonesia, we are using this for power and energy application using our RTUs. Pretty much we are using that. We are working with DNP3, one of the standard communication protocols in power and energy, but still Modbus is still being used and on the downside, on the field level. So that's why it's still I included this case study for this presentation. Okay, downside communicating. I'm not sure if it is either on the smart relay protection or in this switch gears. I believe it's for the smart relay protection for the Modbus RTU. Okay, and then last for the application, we are currently developing one temperature monitoring system in another semiconductor company. So we would like to monitor the temperature on these machines. These are, I believe, some an oven for the wafers or our IC chips. Okay, and we would like to monitor the temperature. So we have here a potential an RTD input connected to our. So this is an electrical signal resistance. We need an I/O module to convert that to digital signals, and we send that to the web access, in which we have the SCADA to create the dashboard, okay, or some computation, some reporting. And then we send that since our web access SCADA is a web browser, meaning you can just open your Google Chrome, even your phone, and access the IP address of your SCADA. And then you can view the dashboard itself. So this is our solution. So once the server was able to process the data, it can also display the data on a wireless TV. Let's say on the production line, if you can imagine your TV, just plug in a USB dongle key, and then open a Google Chrome, plug in the what do you call this, the IP address of the SCADA. Then you will have remote connection, wireless SCADA. Okay, so you don't have to call the operator on the control room just to, hey, what is the temperature of this machine? You don't have to, because from your phone or from your TV on the production line wirelessly, without any hardware, without any additional hardware like PLCs, you can already have the dashboard capability. Okay. Okay, so thank you very much. Actually, this is just the last part. As part of my closing remarks, I would like to invite each and every one of you, especially to the ECE professionals out there, to check out our IIoT Academy. If you'd like to know more about Modbus and other industrial IoT related products and application, check out our IoT Online Academy. That's free and certified courses that you can enroll yourselves into. No payment. You just have to register. Okay? Yeah, no payment. Just go to this website, academy.advantech.com. Again, we offer certification courses, okay, and several. I don't know if I think it's more than 500 courses, 1,000 courses, and these are the topics. So our Modbus falls under industrial IO. Okay, industrial IO, and we can say something about industrial connectivity. But if you can just see the variety of courses that you can check. So it's, even though this is Advantech, okay, Advantech platform, it's not discussed. We are not going to discuss, well, we are discussing our products, of course, but we are also discussing the concept behind the product. You can learn basic automation principles without discussing any products related to the topic. Okay, so this is a very good tool. It's free. Online, of course, it's online. And you can, and we have several what do you call it, levels indicated as you can see here. Okay, these are the topics that you can just click. It consists of PDF, PowerPoint presentations, and video. Okay, and it's categorized depending on your level. We have the basic, usually introduction. Okay, for the basic. Advanced, we can say configurations. But for the professional levels, this is reserved for our application engineers, our system integrator partners. For example, if you're going to integrate our device, for example, our device, our gateway, you would like to integrate, you would like to send the data to the MS SQL server or database, then it's covered under the professional level. Okay, so I'd like to see a lot of registrants from the Philippines, especially from the ECE, to check out this one. Okay, to check this opportunity for you. For any other questions and inquiry, any IIoT related inquiries, again, I am Engineer Aaron Javier, RE, Business Development Manager and Sales Application Engineer of Advantech Philippines, and our channel partner, Amarantos AMTI, with my email address here, aaron.javier@amti.com.ph. Feel free to email me for any technical course. We offer free consultations, product selections in terms of sales, applications and troubleshooting, anything related IIoT. We can support you on that one. As long as it falls under Advantech product line and expertise, we can support you. And with the help of Advantech team, Advantech Malaysia, and Advantech HQ. Thank you everyone for attending this technical topic. And good evening again, and maraming salamat po.
Thank you so much, Engineer Javier, for allowing us to have you with us today and for your very informative and elaborate discussion about Modbus protocol. And since masyado na pong late, sabi po ng ating mga participants, and marami pa rin naman talaga tayong questions sa ating Q&A feature, you can just email your questions to Engineer Aaron Javier's work email para po ma-cater at ma-entertain ang inyong mga questions. So let me just share my screen. So once again, on behalf of IECEP Incorporated, thank you so much, Engineer Aaron Lennin G. Javier, for having that elaborate discussion about data acquisition through Modbus communication protocol. Engineer Javier, please stay on the spotlight as we present to you this plaque of appreciation. The IECEP Incorporated awards this plaque of appreciation to Engineer Aaron Lennon G. Javier in grateful recognition of his expertise, professional competence, and invaluable service rendered as a resource speaker during the 71st Annual General Membership Meeting and Convention with the theme of embracing digital transformation in the time of new normal. Given this 29th of November 2021, signed by Dr. Lori Liza D. Bulaog, PECE, the e-AGM 2021 Convention Chairman and the current Secretary General, and of course, signed by Dr. Michelle D. Lawas, PECE, the current President. Once again, sir, thank you so much for letting you have your time with us today.
Salamat din po sa extension.
No problem, sir. Maraming salamat po on behalf of IECEP Incorporated. And once again, just a gentle reminder that the evaluation and attendance links are already posted in the chat box for anyone who have not yet filled them out. Maraming salamat po. And ayan, ito na yung pinakahihintay. Alam ko na may mga trabaho pa po ang ilan sa atin bukas. That concludes the third day of this year's annual General Membership Meeting and Convention, or dubbed as e-AGM 2.0, with a theme of embracing digital transformation in the time of new normal. Before we end our day, let us have a quick sneak peek of what will happen tomorrow during our day 4. We'll be having another set of technical sessions from 2 different tracks. For the broadcasting and telecommunication track, we would have Engineer Bondi P. Manalo to discuss over-the-top technology. That would be followed by a session with Engineer Carmelo R. Alcala to discuss information technology governance for the ICT and emerging technology. I know, with this sneak peek, we will see you again tomorrow for sure. And of course, our 8-day event, day 4 will be hosted, or our moderator for tomorrow, day 4 would be Hendrix M. Bautista. And once again po, our 8-day event would not have been possible without all the hardworking committees who have been dedicating and committing their time to make e-AGM 2.0 possible. Salute and commendation to the technical team, the post-event completion task committee, the program coordinators, our moderators and hosts, Ways and Means, the correspondence team, the Committee on Awards and Recognition Materials chaired by Engineer Raya Marie Palma, the Committee on Souvenir Program, our graphics team, and the Promotions and Marketing Committee with the assistance of IECEP National Publications Committee. Maraming salamat po for working as one team. We would also like to specially mention the dynamism and attentiveness of our Secretariat, Miss Marian, Miss May, Sir Arvin, Sir Cesar, and Miss Pam. Thank you very much for tirelessly working behind the scenes and ensuring the smooth facilitation of the event. And of course, we would also like to acknowledge our sponsors who are very much instrumental in the conduct of this event: Wireless Link Technologies, AWS Distribution Philippines Corporation, Siemens Energy, Advantech Corporation Malaysia, and AMTI. United Electrical Specialists Incorporated, PT Cerna Corporation, Excel First Review and Training Center, Allied Telesis Philippines Incorporated, Panasonic Business, Infinite Care Technology Solutions, and Sig State Power. Thank you so much for sponsoring this event. And of course, lastly, to our attendees and participants who have been so patient, we are very much thankful for all your support. Kaya muli, maraming salamat po sa inyong lahat. Patuloy po nating suportahan at mahalin ang ating nag-iisang organisasyon. We hope we all learned and enjoy our day today. And of course, let us all continue to be more socially and professionally responsible in building our nation as electronics engineers. Kita-kita po muli tayo sa mga susunod na araw, mga ka-IECEP. Maraming salamat po muli sa inyong lahat.